Gaurav Agarwal. I'm product manager at NVIDIA, and I manage the G-Sync line of notebooks and desktops as well as gaming notebooks. What we have here is the Clevo P750ZMG. It is a 4K laptop, 4K screen, 15-inch display, and it's got G-Sync on it. So if you were to compare,
what are we playing here?
we're playing Shadow of Mordor here. And if you were to pan the camera around in this game, you can kind of see that the background has a lot of stutter. It's not smooth. There's a heartbeat as the game moves around the camera. And let me now switch to G-Sync mode. So the V will now become a G as I enable G-Sync mode. And there you have it. It's buttery smooth.
So what resolution is this notebook?
This is a GTX 980M notebook. It's got a 4K display panel.
4K G-Sync.
4K G-Sync.
Wow.
There you are. That's just one of the notebooks we're introducing. Here is an MSI GT72. It's got a 980M GPU, GTX 980M, and it's got a 1080p panel at 17-inch display. What's interesting here is just how severe the differences between G-Sync and no G-Sync. So here is I've disabled G-Sync and V-Sync, right? So this is a no sync run, and you can see the curtains there. There's a lot of horizontal tearing. It's almost like a swimming effect as you pan the camera, and this is very disturbing for gamers. It's not a good effect. As I enable G-Sync, and you'll see the letter on the top right turn G, that's G-Sync, all the tearing is gone. It's buttery smooth.
Is this A/B comparison something the users can do with the driver, or this is just for demo purposes here?
It's for demo purposes.
Okay.
It's because I think this best shows the value that G-Sync delivers. But gamers can always go into the NVIDIA control panel and enable or disable G-Sync.
Yeah, obviously because of the delay between doing that, sometimes you don't get the full comparison of doing an A/B comparison because there's so much time delay between changing the setting.
But we expect that if users buy a G-Sync notebook, they would play with it with G-Sync on. There's no reason to put it off.
Yeah.
So, here I have the Asus G751. This is got a 980M GPU, 17-inch display, and the same resolution 1080p. We're showing Grand Theft Auto 5 here. As we pan the camera with V-Sync on, there's a lot of stutter. You can almost see a vibration on the palm trees, and there's a lagging image as I pan the camera. Now let's turn V-Sync off and G-Sync off, and now you can see the tearing, horizontal tearing swimming effect I talked about before. Now this is G-Sync on. It does not have the tearing we saw before.
Wow.
The smoothing, it's a lot smoother than any of the previous ones.
I advise my users to actually look at a comparison using a game and not the pendulum demo. It's a bit more obvious doing a 360 pan in a game than the pendulum demo, which is pretty much 2D, as we're going to look at the pendulum demo in a second.
Now let's move on though. Here we have the Aorus X5 notebook.
Yeah, this one we're quite interested in for size.
And it's interesting. It's got a 15-inch resolution, 15-inch display, 3K resolution. And what makes this different than anything we've seen before is it's got an SLI configuration GPU. So yes, G-Sync is supported in SLI. This has a 965M GPU. And let's compare the experience of running without G-Sync. So you can see like a horizontal tear as the pendulum is moving across your camera. There it goes. There's a moving line there. And when I switch to G-Sync mode, it's gone.
We might also want to show our readers the tearing test.
Yep. Let me actually kick that off again.
Yep. That's one. So as you can see, we're doing this for real. It's not tricks.
It's not doctored in any way.
Yep.
So you talking about the test pattern?
Yeah, the tearing test. Okay.
Right. So this is running in G-Sync mode.
Why is the red flashing? Is that because it's early or?
No, it's whenever I apply an input, there's a red flash.
Okay.
Just how it's
That's
made.
fine. because it's resetting the pipeline.
Exactly. But
Oh, that's bad.
That's no sync.
I think that's a bit more obvious in terms of our video log here to show this test and the other one. That's really bad.
But the key thing is, if you were to look at a vertical geometry in a game and you were panning the game across, and there was movement, you would see similar tearing.
Yeah. And what refreshes this panel? Do you know?
This is at 60 hertz refresh.
60.
And now let's turn G-Sync on. You'll see that all of that is gone.
There we go.
There you have it.
And let's show with VSync.
VSync is right here.
Yep.
So in this particular demo, we've set it up to always do no sync versus G-Sync. And that's a setting we did in the control panel.
Oh, so you've done the override. You've done that's fine.
Setting, but
We've seen the A/B comparison here anyway.
That's all your G-Sync demos. It's good.
And we'll go over the warping.
Yeah, the key thing with the warping is that the user experience of turning multi-resolution shading on versus off is the same. You don't need this actually.
Yeah, we're just showing we're using. So this is the latest development kit, not the retail.
Correct. This is the Crescent Bay prototype by Oculus.
Yeah.
And what's key is...
And this technology is going to support the new headsets, HTC Revive with Valve, and all you guys, you're working partnerships with all the other ones.
That's correct. Now let's look at this. Let's look at what I want you to focus on here is this. This here is the image that the users are going to see when they look through their virtual reality headsets. This has no resolution turned on. I mean, this has no compression turned on, right? So this is the default that you would see today. But then as we drop pixels in the render process, what I want you to focus on is whether you can tell if there's a difference in what the gamers see.
So this is our representation here of how much we've dropped.
There, we've turned on the resolution, the dropping, and now if you look at what the gamers see, it looks the same. I'm going to increase the compression factor, which means I'm dropping more and more pixels.
Yeah, we can see here that's 40%. That's quite significant.
Let me max it out. Sorry. There you go.
That's pretty much the equivalent of adding a second GPU here.
Yeah, it's almost dropping half the pixels. And what's key is the user sees the same image. It looks no different.
And can you just explain, we talked earlier about the multi-resolutions. So we're now, first we've talked about the optical correction where we skip pixels that are not needed because of the vision, but you've also talked about earlier how the multiple resolutions in terms of to improve the picture. Can we just explain that?
Yes, so because we now know as part of the warping of the image, we are dropping pixels at the periphery of the image. That means we were rendering pixels which we never used. And now we're using that fact to actually not render those pixels anymore. So as part of increasing the compression here, we are dropping pixels from the render process. So Maxwell is rendering an image which has different resolutions in different parts. And so it's now saving pixels which game developers can use to speed up the VR experience.
And so is that where we get the multiple resolutions from? So we save the pixels and we layer the extra saved resources to improve the picture, is it?
Exactly, that's right. So we drop pixels at the periphery of the image, which now means that the GPU has more horsepower available to speed up the game.
So, okay, let's say for example we did a 2x saving. How much resolution do we increase?
How much resolution do we...
If we implement the additional, we talked about the what's the term called?
Multi-projection?
Multi-projection.
Yes.
How much resolution? Was it a linear like 2x, or we get less or more?
So at the highest resolution, highest compression factor, you get a 2x speed up in pixel shader performance, which roughly translates to half the pixels dropped.
Yeah.
Now, what that means for each game depends upon each game in particular.
Okay.
Some games tend to be more pixel heavy, some less.
Okay, so it depends on the developer how efficient they are in terms of doing their textures and the resources and all that sort of thing, in terms of to add more details.
Right. Scaling around the periphery, and the image where we scale down the periphery, and then we can increase the compression factor. And maybe you can try and pick a difference. Come on, it's not that hard.
I mean, I'll give it a shot. But...
Yeah. Just tell me if you can tell if there's a difference.
So which mode is this?
So this is the original. This is without any scaling down of the periphery.
Yeah.
So now we're going to enable multi-resolution shading,
Okay, so with compression.
and it's also compressed here, right? So
Oh
it's
wow.
Oh wow,
That suddenly
nothing.
that suddenly became really rather lovely actually.
became better.
Just a little bit.
And now Chitoku can increase the resolution, the compression.
Yep.
So you're going to actually see more and more scaling at the periphery. And just keep an eye out to see if you can tell a difference.
Earlier, when you were describing the warping of the VR frames to suit the optics, and the GPU is not rendering certain parts of the frame, are those pixels, so the black area, actually being skipped, or them being rendered and then being culled later?
Before, these were being rendered and not used. Now we're not creating them at all.
At all?
At all.
Okay.
That's why games will see a speed up
I'm
now.
going to switch on and off, alright?
Yep.
So this is without the compression, without the multi-resolution,
Yeah.
and with the multi-resolution. You probably don't see.
Not very little, if any, difference.
And with the multi-resolution, but at maximum compression settings.
Okay, let's make it.
This is the maximum.
This is maximum.
This is an NVIDIA demo or an Oculus demo?
This is an NVIDIA demo.
Okay, so this is just a test case to show the new warping features.
Correct.
Okay.
So interesting. You can turn around and it's just. It looks like a door. It's there, but it's not there. Oh god. I feel like this is most strongly enjoyed in one's own home, with the doors locked and the lights turned out, and no one else there.
That's just 4K.
Okay, and what is this? Where we'll go? This is GTA again.
Yep.
This is on a single 980 Ti card.
And can we have a look at the details on this one? Can you?
Sure. Although I might need to change the language because.
I just want to prove to my viewers that you're not doing anything silly for the graphic settings for demonstration purposes.
It's in Japanese now. We're just going to make it English.
That's fine. We have we have a comprehensive benchmark benchmark article anyway. But I just want to. All right, so we got here. They're all up, and TXAA is off.
Yeah. Well, it says off. So MSA is off.
Yeah.
FXAA is on. Those are texture ultra high, shader ultra high.
Can you show me the second one there?
Sure.
This, yeah, that's fine. We're used to it. The one under that one.
Yeah. These,
That's okay.
All right.
That's fine.
which one?
And so
Long shadow.
we're running we're running GTA 5 on this machine in G-Sync on.
Has no
Yes,
compression.
yes.
Okay.
So this is the original image.
So
And now I'm
okay,
going
let me
to
go back
enable
to the
compression.
game.
So you
and
will,
if I
and I'll tell you
pan,
when, okay? Hang on.
Because what we found with GTA, obviously, it's a very demanding game,
yes, it is.
and tearing,
Hang on.
tearing is
Okay, now I'm
important,
enabling
and
compression.
because we can't get a high frame rate, G-Sync can help.
Exactly.
the difference.
It is almost impossible to
Okay,
achieve
now I'm
like
gonna
always
increase the
60
compression, so I'm
FPS
gonna
at
drop more and more
4K.
pixels.
Yeah, we found in our testing, we found we need 2 cards
All right.
minimum.
Right. So it is. SLI is sort of recommended if you are to test
At this
4K.
point,
And what is this machine? This is a Tiki, or what's this one?
This one, it's not Tiki. It's just
Small form factor.
small form factor mini ITX motherboard with single 980 Ti.
Okay.
But this is the maximum
So
compression.
there is
setting.
no way to fit like 2 cards in it.
Sure.
So you mentioned how you can do
But
civil
with G-Sync, even at
Yes.
4K, this can, achieve a decent playable, experience.
code for that.
The developer will have to.
It's quite cool as well. How long this been running?
And as long
Well,
as
it's
you
been
use our
running
VR
only for
library,
like
Gameworks VR,
the last 5
you get
minutes.
that
But you
by-
can.
But still, I mean, just from a touch base, it's quite cool. So this,
Yeah,
the combination of 980 Ti cooler and this chassis is working quite well. So it's quite impressive there.
Right. I had this running overnight actually for like, a couple nights actually, and it was fine.